point there. And this shows that if you take a straight line molecule the way it's drawn, it almost never occurs that way. And it actually always shows up, almost always, as ring structures. And again, we don't need to go into the details of that. But I brought a couple of these to pass around. This is a molecule of glucose. And it gives you an idea of the way it's structured as a ring. And at every carbon, there is this part. This is an entity that's fixed in space. Now, if this is a sweetness receptor, then the relationship of these OHs on the outside has to be exactly right to fit in here, to trigger that response that will go to the brain. Right? And if this doesn't fit exactly right, maybe it fits a little bit but not too much, then you're not going to get as much of a sweetness effect. If it fits perfectly, it might be a powerful sweetness effect. Now, if I were to take this molecule and change it from glucose, and all I have to do to make it into a different molecule is flip at one carbon, now I've got galactose. Lactose is nowhere near as sweet. Right? So there's something about the conformation of this molecule and the receptor that either works or doesn't work very well. Right? So if you've got glucose, it's going to be as sweet as glucose no matter what. And if you've got sucrose, it'll be the sweetness of sucrose pretty much no matter what.
Glucose molecules, would they ever attach in a circular pattern?
Yes, good question. And in fact, the last thing so I have to carry this the next time. This is what's called a cyclodextrin. There are 6 glucose units, and they actually go head to tail. And in fact, this is a molecule that's useful in food technology because you can see it has an open spot in the middle. And this would be a typical flavor molecule. This might be menthol. I forget what it is. It might be menthol. But a lot of flavor molecules are of a dimension where they can fit right in there, and they can be stable this way. So you could actually make a flavor in a product that will stay in the product until, say, the product's warmed up a little bit. And one way to warm it up a little bit is put it in your mouth. So you can sort of control flavor release by looking at interaction of carbohydrate and flavor molecules. Yeah?
Is that how cotton candy works?
I'm not sure how cotton candy works exactly, but cotton candy is an amorphous form. It's not crystalline, and it's not circular. I think it's just non-specific flavor binding to it in color.